I am David Eldon, and I will discuss regression tests in OMFIT. First, we'll go over the purpose of regression tests for you who doubt their value. We'll talk about the regression test area and the tools for loading and running tests. The OMFIT test class, which facilitates reporting test results to GitHub, Slack, and email. Automatic testing and GitHub test status. And then some guidelines that I feel are helpful, although I didn't make them up, for making effective tests, such as making the test units of code, the small tests on focused small units of code where possible, and the assert statement. So the purpose of regression tests are to protect your code. If some user wants to merge code into the repository, they have to run a regression test first. When the test fails, it notifies the maintainers, and that new code is prevented from being merged until the problems are fixed. It's protection for the tools you want, so you should do it. Okay, OMFIT has a regression test area in the regression folder. It's full of a ton of different tests, as you can see here. This isn't even all of them. It goes on. If you want to run one of these tests, the simplest way, if you have the GUI open, is to go File, Load Regression Script, type in a filter here, pick a test from the box, press OK, and it loads into the tree. Then you can double-click it, and it runs. You can also run these directly from the command line by typing OMFIT regression test template.py, or the name of whichever test you want. If the thing needs a GUI, include the -G flag. Some of the tests are so simple and test basic classes that you don't even need OMFIT. You can run them in basic Python. That's not generally true, but it is true in a few cases. The thing will run and will print its output, and then you can see if it passed or failed. Now, if you test a simple little function, just pass fail is enough. But if you test a huge workflow that's divided into little subtopics, you may want to organize your test results in a more methodical way. In order for me to do that for myself, I created the OMFITtest class. This thing is for helping organize and communicate test results. It has options like posting status updates on GitHub, printing formatted results tables like this one, and exception tracebacks. It can post comments on GitHub, including the stuff from the print, like it can comment with all your exception tracebacks. If you run a remote server through No Machine where you can't copy paste because of bugs, you can have it run on Iris and then email you the exception tracebacks or post them in your thing. It can also do Slack reports. If you want to use this is how you can get started. There's a script called regression/test_template.py. Just copy this class test OMFIT minimal out of there, make your own copy, and you can start editing it. The way these are launched is with this manage test function. So here, after you've copied it, rename it. I renamed this test crazy example. This name should be descriptive of what you're trying to test. So when test crazy example fails, you know your crazy example sucks. Then replace its methods. So it used to have test thingy in it. Now it does test molt versus add and test power versus molt. These short names are already descriptive, so you know there's a problem with molt versus add if it fails. And then you can give it a doc string to expand on what it's doing and why you wrote this test and what it means if it fails. So it's just asserting that x plus x plus x equals x times 3, which would better be true. So it's a dumb example test. And you can populate this with some huge list of test methods testing specific little units of your code. And then you can write a bunch of different classes together and combine them. Manage test accepts either one instance of a class that's based on OMFITtest or a list of them. And there are detailed controls for telling it to do them under one context or separating the context with different classes. And the instructions for those customizations are in the documentation of OMFITtest and manage test. In order to control details of OMFITtest's options, you can just write them into the top of the class, and they're attributes of the class itself that you're creating. For example, this is the test Elm processing module class, which is based on OMFITtest. And I'm telling it notify GH status equals true, which that turns on GitHub status updates for the class itself. So after this runs, it'll post a pass or fail status on GitHub. I also told it GH individual status equals true. This affects the individual methods. Remember, this is made up of a class and then these test methods. So the first one does the status for the class itself. This does it for all the methods. 0 means no status posts for the individual methods. 1 means all of them, and 2 means only if they fail. So if the class fails because only one of its methods fails, it'll post 2 failed statuses. So you'll see the class failed, and you'll see the specific part of the test suite that caused the problem. You can also tell it to load modules. The test Elm processing module class asks to load the Elm processing module. And when it loads it to the tree, it'll append _test copy. So if you already had Elm processing in there, it won't overwrite the module you're using. It'll test in its own module instance. Okay, you can also put any kind of information you want in here. If your test needs a default shot to run, you can give it a default shot, and you can access it later as self.default shot in your methods. But you don't have to, but it could be useful to have. I need a default X array. I need an array that's some length every time I want to do X, test X squared, whatever. You can just put that, whatever you want, into the class instance yourself.
Yeah, those are just attributes of the class.
Yeah, they're just class attributes.
You can write whatever you.
Yeah, I found it convenient to store shot and stuff in there. If you want more examples of how this works, you can look at regression/test OMFITtest. This tests the class itself and all of its options, which means it has example usages of all those options. There's test SolPS, test OMFIT Elm, and you can find others by grepping for OMFITtest.
You should use git grep instead. Are you familiar with git grep?
Why?
You don't have to do -r or give it a path. I'll just search the whole repository for you.
Then you'll get instances in classes as well. Okay,
Well, you can still give it a path.
Okay. All right, automatic testing and GitHub test status. For those of you who haven't noticed, GitHub has this status feature. You can see these red X's and green checks next to commits. And if you click on one, it elaborates, saying this, for example, this commit passed 50 individual checks. And there's a big long list of them. It sorts them so fails are at the top. So if it passes 48 and fails 2, you can see the 2 that failed. And you don't have to scroll through all 50 of them. It also has a pending or expected one. The way that works, for example, is there's this test context that's required. And this gets put on with a yellow dot onto every new pull request, saying it's expected that this will pass, and you can't actually merge into the main branch of the repo until you do pass this test. This protects us from some user who wants to commit lots of bugs. And the way this works is we have an automatic testing machine called the Mac Mini OMFIT Regression Test Invigilator, or Morty. Morty searches for these labels at the top of tests, and also which files change in a pull request or commit. Based on the intersection of these files that change and the labels in the test, Morty picks a set of tests to run, runs them, and Morty does his own test context, but individual tests, if they're set up to do so, will also post their own test status. And then from the status, you can see which ones failed. If the tests do not use OMFITtest or haven't manually posted GitHub status messages, it could be difficult to understand exactly what failed, but there are logs and it can be done. I find it more convenient to have these statuses posted from OMFITtest, but it's not the only way to do it. Okay, if you're going to have all these statuses, one recommendation I have is to test small units of code where possible. If you're using a test called test all of OMFIT, where do you start looking for a failure? The giant integration test is nice because if it passes, you know everything is fine. But if it fails, you could end up reading a very long traceback, and you could get to the bottom of it, but wouldn't it be nice if your test instead said test function 1 in mode 2? Then if it fails, you know function 1 is bad, only in mode 2. And it zooms you in, so you start in the specific area where there's a problem, and you can deal the shorter traceback. Again, OMFITtest has this GH individual status equals true, which only posts status context for its test methods if they fail. So you'll hopefully get a short list of focused problems, and you can do surgical strikes against them to solve your issues.
I don't think that's the default though, right?
I don't remember what the default is. Maybe it is. OMFITtest prints exception reports to the OMFIT console and formats them nicely, and it does one per failed test method. So if you have a test suite made up of like 20 methods, you can see all the failures, and they'll all be narrow, so you get a very detailed granular view of what's going on. Finally, I'd like to talk to you all about the assert statement. This is the best statement for tests. It works like this. You can assert true equals false, and it raises an assertion error. If you include a comment after true equals false, it plays back that comment after it does it. A more advanced usage is like this. Let's say you have some function. This is just a stupid function that adds things together. I have some inputs, and I tell it the expected outputs. Then I get the actual outputs by running the function with the inputs. And then I loop through the actual outputs and the expected ones, and I assert actual equals expected. And the message is expected thing to be value, but got other value instead. So it looks like this. Expected var3 to be 2.23, but got 0 instead. So it says, hey, guy, I mean, this is what's wrong with your test. Then instead of reading a key error, why do I have a key error? It tells you, buddy, you did it wrong. You did a bad job. It's supposed to be this. And if you write these nicely while you're writing the function you're trying to test, you'll know what it's supposed to do at the time. It'll be fresh in your mind, and you can describe to your future self what it's supposed to do. Then when you come back in a year, it'll say, hey, you know what? You're talking to yourself and explaining what it's supposed to do and what it's actually doing. And if you do this carefully, it can make things a lot easier. So, in summary, I recommend that you write regression tests for everything you do. I find it helpful to write tests in parallel with the things they test. I mean, when I'm developing a script, I run it when it's incomplete to make sure it works. You know, when the first few lines, do they work? Does the first unit work? And instead of running those manually, if I write a test, I can run the incomplete test in the incomplete script. And then by the time I'm done with the script, I'm also done with the test, and then anyone who wants to change it has to deal with the regression test, which will now be run automatically. I like to use OMFITtest. It helps facilitate communicating with GitHub. It also prints nice results tables, which you can customize, but it's not strictly required if you don't want to deal with it. Separate tests into focused functions that are named for the specific things they test, and pepper the test with the assert statement. Like half the lines could be assert. There's no too much. That's it.